What if I told you there's a way to solve some of the most classic, maybe even most dreaded coding interview problems in, like, a single pass? Today, we are going to see exactly how hash tables make iconic problems, I'm talking two-sum and anagrams, feel almost ridiculously easy.
So let me just ask you straight up, how do you solve these problems in linear time? We're going to toss out those slow, clunky, brute force methods. The real key here is to start thinking in terms of instant lookups, and well, that's exactly where our secret weapon comes into play.
And this slide right here, this is the why. Over on the left, you've got your standard brute force approach. That O of n squared, that means nested loops, and that means slow. But on the right, you have the hash table solution, a beautiful, clean O of n. That is the kind of leap in efficiency that makes interviewers sit up and pay attention.
So let's talk about this secret weapon of yours, the hash table. Honestly, this data structure is the absolute key to unlocking those lightning-fast O of n solutions for a massive category of interview questions.
You know, the idea behind it is actually super simple. Just picture a huge wall of lockers. You've got a key, let's say it's someone's name. A hash function is like a magic rule that instantly tells you which locker number to go to. From there, you can either put something in it or see what's already inside. And hey, if two keys happen to point to the same locker, that's called a collision, and we just have a simple system for them to share the space. No big deal.
So, to put it a little more formally, a hash table is just a data structure that maps keys to values. Its entire reason for existing is to make finding things, looking them up, incredibly fast. And it does that using that special hash function we were just talking about.
Now this is the most important part. O of 1 time. That means, on average, the time it takes to add something, find something, or delete something is constant. It literally doesn't matter if you have 10 items or 10 million. The time is basically the same. And that is an incredibly powerful property.
All right, let's put this into practice. We're diving into our first challenge, two-sum. And we're going to see how to take a clunky, nested loop solution and transform it into a sleek, single-pass masterpiece.
So here's the problem, and you've probably seen it before. You get a list of numbers and a target value. Your only job is to find the locations, the indices, of two numbers in that list that add up perfectly to that target. A true classic.
So how do we do it in just one pass? Easy. We start with an empty map, which is going to act like our memory. As we walk through the list, one number at a time, we ask a simple question. For the number we're on, what's the other number we would need to hit our target? We call that the complement. Then we just check our map. Hey, have we seen this complement before? If the answer is yes, boom, we're done. We found our pair. If not, we just add the current number and its index to our map and take one more step.
And what about performance? Well, on average, it's O of n time because we only have to touch each number once. You do need O of n space for the map. Now, you might see that O of n squared worst case and get a little worried. That's only technically possible if, like, every single key collides, which, with any decent hash function, is so astronomically rare it's basically not a concern in an interview.
Okay, on to our second major pattern, cracking anagrams. We're going to use the exact same core idea of a hash table, but this time we're using it to count characters. It's a super efficient way to check and group strings.
The challenge itself is pretty simple. Are two strings anagrams? In other words, do they have the exact same letters used the exact same number of times? You know, like listen and silent, that's a yes. But rat and car, that's a no.
The strategy here is all about counting. First things first, a quick check. If the strings have different lengths, there's no way they can be anagrams, so you're done right there. But if they're the same, you build a frequency map for the first string. Just think of it like dumping out a bag of Scrabble tiles and counting how many of each letter you have. Then you go through the second string, and for each letter, you remove one of those tiles from your pile. If you get to the end and your pile of tiles is completely empty, well, you found yourself an anagram.
So the complexity here is O of n time, where n is just the length of the strings, and the space is O of k, where k is the number of unique characters. Now, if you're just dealing with, say, lowercase English letters, k is just 26. It's a constant, so this thing is incredibly efficient on space.
Okay, so you have the code for the optimal solution. But in a real interview, just writing the code is only half the battle. Let's talk about how you discuss your solution with confidence, showing the interviewer that you really get the trade-offs involved.
First, let's talk about the common traps you need to avoid. Remember, O of 1 is the expected time for a hash table, not a worst-case guarantee. Always think about how you're handling duplicates in two-sum.
Make sure you're clear on whether you need to return the numbers themselves or their original indices. And for anagrams, you've got to ask about the rules. Are we ignoring case? What about punctuation or Unicode?
This right here is a perfect example of a trade-off discussion. You could solve the anagram problem by just sorting both strings and seeing if they're identical. It's really simple to code, but it runs in O of L log L time. The hash table counting method we just did, that's more efficient, at O of L. Showing you understand this choice is huge.
And here it is, the money quote. If you want to sound like a pro when you present your two-sum solution, say something almost exactly like this. It's clear, it's confident, and it shows in one sentence that you've already thought about time, space, and the assumptions you're making. It's just perfect.
So to really nail the interview discussion, just run through this mental checklist. State your assumptions. Clarify the requirements. Talk about edge cases. What if the input is empty? And finally, briefly mention other ways you could solve it and then explain why your way is the best fit. This shows a whole other level of understanding.
So the big takeaway here is really simple, but it's so powerful. Hash tables are your go-to tool. They take problems that seem all tangled up with searching, comparing, or counting, and they turn them into these clean, elegant, linear time solutions.
Look, once you master this pattern of thinking, this instinct to reach for a hash table for instant lookups, it completely changes how you see a whole class of problems. So really the only question left is, what problem will you solve next with a hash table?